Hello, everyone. Here's the video on data processing that I announced a few days ago. And in this video, we will look a little bit at an example of data processing where we'll download a file from the ISTAT website. And on this file, we will perform some processing and then a minimal presentation. Actually, the presentation itself is the most sacrificed part due to time constraints, because I want to focus on the problems that arise from the difficulty of performing the download, what they are, the phases that one must go through. And before showing you the actual video, the actual example, I will show you a presentation where we discuss a little bit about the phases that one must go through to carry out this type of problem, to solve this type of problem. So if we need to perform data processing, we can distinguish, let's say, about three main phases. Downloading the data, I use the term download here. Other terms can also be used. Processing and then presenting the results. This is quite obvious. All three phases are very important. In the download phase, the first thing you need to do is have the ability to open the remote file. Very often this data is stored in a database in a remote repository, and you need to be able to open it. It is much more useful to use the tools I will show you when there are many files to open. When we have a single large file, we can perform the operation manually, that is directly by giving the command directly. When there are many small files, then it becomes useful to automate the operation. And this is already a program. In the program, in the example I will show you, we actually have a single large file. However, it is very simple. Once you know, let's say, the basics of Python, to be able to expand on this and move on to having, to opening many different files. Obviously, this entails knowing what the structure of the site is, having accessibility to the files, and a whole series of issues. Here, let's say I will only touch upon them with the word access, in fact. I indicate this whole series of issues by saying how to get access. Essentially, once you have the URL of the file or the URLs of the various files available, then you need to build a little program that does this type of download, and it can be done. Let's see, however, what other problems are encountered in reality. The data transfer itself, actually. The opening of the file and the data transfer happen in with the same function. However, they are two somewhat different operations. When opening the file, it is necessary that certain conditions related to the file extension, which then determines the file type, are recognized by the program that has to perform the download. And this can lead to error situations. Other obvious things are that, for example, the file must be present and available, it must be open for the download, etc., etc. Then the actual transfer takes place. In the case of the transfer, the problem is the size of this file. If this file is very large, it can create problems with time. The transfer operation can take too long, and this is where bandwidth becomes essential. So bandwidth is another one of the resources, let's say, that we need to deal with problems of this kind in general. Once we have the file transferred into our memory, a different problem arises. We need to interpret the content of the file correctly. There are various formats. Some formats contain metadata, but sometimes this doesn't happen. So there are formats like XML, JSON that have the possibility to, quote unquote, explain themselves to us by giving a label to the individual pieces of data. Other formats are more basic, and often one has to reason with these, therefore entrust in some way, always associate metadata with the data, give an explanation, give a meaning to each piece of data, and give it a format. This is where the problem of encoding arises. That is, the data must be interpreted with the correct type of encoding. Assuming that we are dealing with alphanumeric data, because in most cases, what we find on the web are used some alphanumeric encoding formats. We need to find the correct form of encoding. If there are problems, and perhaps you find an encoding form that is similar to the correct one but still leaves some errors, you can make some small adjustments. For example, in the program I will show you, in the example I will show you something of this kind. After that, you need to organize the data. You need to organize the data based on already starting to think about the problem and how you want to process them. And so we have a phase that I have defined as reorganization or arrangement. You need to choose what type of structure to use to be able to host the data when they are, let's say, within our processing system, either in mass storage or in main memory. This is where the study of Python libraries comes into play, which is essential. NumPy, for example, pandas more for the transfer. NumPy, for example, provides us with some data structures that have many features. It depends on whether the format is more or less numerical. Obviously, this is just the base. Then you need to go and specify. Having done this, decide how to store the data on your system. And here we can have different solutions. We can have, or the most typical solution is to recreate the file, which could also be the original one. It would make us skip all these things. Well, it can be a file built by us based on our needs with saved on local mass storage. But there is also the database solution that is building a database starting from the data. This is a more interesting solution because it allows us to structure based on the problem we then want to address in the processing. It allows us to structure the data in a more complex, more articulated way. And then in the processing phase, it also gives us the possibility to exploit what I call the database facilities. That is the possibility of using queries to solve many problems that otherwise instead we would require our programming. So in the case of the database, if we want to work with the database, we need to design this database, which is a very interesting part, full of opportunities, let's say. But obviously it is also quite demanding. The more complex the data is, not so much the data itself, but the structure of that data. So the articulation, the relationships that exist between them, the more complex the database turns out to be. There are situations where databases are also built of a non-relational type. That is, databases that are collections of objects, all more or less of the same type. For example, a set of videos with some metadata. So in this case, the non-relational aspect prevails. There are some very interesting situations where we have hybrid situations, hybrid solutions. For example, in the example I will show you, we are moving towards something hybrid. Then we will let's say I will show you where this need arises. The actual processing of the data. So if we are talking now about a situation with the data ready, already present on the local processing system, the data processing is obviously something that cannot be generalized. It pertains to the specific problem. You need to see what you specifically want to do with that data, and that is where it is clear that you reach the maximum level of knowledge, of understanding, of capability on the part of whoever has to work, because you need clearly specific competence also on the problem that must be addressed beyond just the IT one. Very often the ideal solution is to have two experts, one in the specific subject matter and an IT expert who collaborate together. After that, once this problem is solved, and I am clearly talking about phases that can take even months, for example, of work, you move on to the presentation, which is not trivial. Because if you have to somehow talk about let's say you have to quote unquote sell a thesis, demonstrate your thesis, or in any case analyze data for any purpose, you still have to do it in a convincing way and present the data in a convincing way. Here too, Python helps a lot. There are graphical libraries or simpler numerical presentations in case, let's say, we are in a more work in progress situation, therefore a simpler situation. But in any case, the data must be presented in the end. And here too, the libraries come back into play knowing Python libraries helps a great deal. In everything we are saying, one topic, the elephant in the room, one might say today, is artificial intelligence. I mean, in all of this, artificial intelligence can help us. I will show you that I also used it a little bit in this example, and it kind of enters into all these parts. However, the experience I'm gaining by trying out a few of these applications tells me that there are situations where it's more useful and situations where it's a bit less useful. For example, the more mechanical parts, in quotation marks. Why do I say mechanical? Because if we have to explain to the artificial intelligence what needs to be done, and it's a complex thing, we spend a lot of time, sometimes a time almost equal to what a programmer spends building the program. So we should try instead to use artificial intelligence for the, in quotation marks, slightly more standard operations. For example, I inserted it here at the beginning in the access problem. One last thing before moving on to the actual example. Why are there these different colors? Based on the experience of this example that I'm showing you and other examples, what is the points that waste the most time? Let's think about it for a moment. Which ones are more difficult? So clearly, managing file access with permissions, finding the right URL is actually what's most difficult, in my opinion, from a time perspective. That is, it requires having the right information, having knowledge of the site, and sometimes artificial intelligence can really help a lot with this. Clearly, it doesn't help, for example, with bandwidth, which is a hardware characteristic that either exists or it doesn't. For all other things, it can be used. In the database project, it would be very interesting. In the example, I used it a little bit on this topic. We discussed it a little. I will publish everything I tell you on GitHub, including the discussion, so to speak, that with ChatGPT regarding the database structure, which I also think is quite interesting. The other things are mostly quantitative work in the sense that, well, there are difficulties to overcome, but they can reasonably be overcome. Let's say it's something that is more easily under the programmer's control. By the way, for example, regarding the graphical presentation and the libraries, the use of artificial intelligence really helps a lot. So let's say that both the initial part and the final part can be made much simpler, starting from let's say the use of artificial intelligence. What instead remains increasingly the responsibility, let's say, of the programmer is the knowledge of the specific problem, and therefore the implementation of this knowledge in the solution of the problem. All right, now I'll take a short break and then move on to the second part. So what I'm going to do is walk you through the program, and I'll provide a clear outline for you regarding how the code is structured. Well, I won't go into too much detail because it would be too long. Let's say I organized the code into 3 distinct functions. The first one was designed to download the necessary files directly from the ISTAT website. And for that part, I, let's say, delegated the task to ChatGPT, taking the time to explain a bit of what exactly needed to be done to get the data correctly. It was a really helpful way to structure the whole workflow, making sure each step was handled efficiently. You see that essentially, let's say it downloads some files that are compressed and then it decompresses them. I provided the information about the directories, and so this is a fairly standard part. Obviously, I had to indicate what the URL was. In any case, I still had to know what the URL was. And then I gave the possibility, let's say, to build the directory where the data had to be downloaded in the way that I had to indicate. When I show you the chat a little bit, we will talk about this part later on. Then, on the other hand, 2 functions, file uploading. So the file at this point, actually the file was a compressed file that contained many files relating to the individual cities. We are talking about commuting data, well, I didn't tell you this, the topic on which this example is based. And this file load is instead a Python function that I made where these files are loaded into memory from the files obtained, let's say, thanks to ChatGPT. And here is where those problems I mentioned to you regarding encoding come in. You see, just the fact of dealing with the names of Italian municipalities, which contain, as in the Italian language, accented letters, posed some problems because the encoding couldn't be the simplest one that is normally used, which is UTF-8, but it was causing some issues. So I had to specify the separator, and I had to specify a particular format where when there is a character that cannot be interpreted, instead of throwing an error, the code replaces it with the / base code. This way, the loading continues. After that, once you have all the data securely stored, you will find that you have the file correctly acquired. Then you are faced with these specific strings, which are filled with this particular type of complex characters that we need to examine further. Well, then with this type of characters, you need to do a parsing, as they say, that is a sifting of the program, and replace the characters with the correct characters that we see. It's an operation that has to be done manually. It takes a bit of time. It can take a bit of time. In this case, it wasn't very complex because it was very clear that the problem was the accented letters. So the accented letters were recognized and replaced with the correct character. Once we are on the local computer, these coding problems don't exist anymore. But it's not just that. In some data was using the comma within the data and not just as a separator. This posed problems, so I had to specify that the separator was the string terminator here. And here instead I set it so that the data, to avoid this error repeating, I set it so that the data that was separated by commas is instead separated by periods, so a different separator in such a way. All of this came from trial and error, that is from a set of tests which then led to correctly identifying what the problems were and solving them one by one. A bit of time, but they are fairly simple problems. However, it can happen that in certain situations there are so many of these types of problems that this approach becomes impractical. In this case, it is possible to ask for help from artificial intelligence again. Anyway, once this is done, we have the file loaded into memory with the data and inside a structure that is a very simple list. And starting from this list, we build, first we build the database. That is, we create a database on MySQL. And then on this, we build a table. But be careful, all of these are functions. Building the table, populating the table. A table maybe a bit? Yes. How many are there? About 20, 30 columns. Then in reality, the main program is actually this one right here, which is utilized starting from this specific point with some very specific data inputs. Since this is just a test scenario, I have gone ahead and embedded the data directly into the program code itself to keep things simple. So we have the call to the first function, and then there are the calls to the other functions, which are commented out at the moment, because the execution of this program takes about an hour, 1, 2, even 2 to read all this data and build the database. And so to avoid running this program inadvertently, since the operation of building the database deletes the previous database, I put in some comments so that it cannot be launched, let's say, inadvertently. But clearly, if you want to try it, you have to uncomment all these lines that are here. So you will find the data commented out, possibly in the version I put on GitHub. I will remove these comments and leave the, let's say, loaded version in quotes of this program. So it's a simple little program, 1 or 2 hours of processing to load this data. Why? Well, these commuting data, I tell you, are very specific data, very disaggregated. They relate to the 2011 census, which is the last traditional census carried out by by ISTAT, and they describe commuting not only from one municipality to another, so there is a row for every single transfer, but even in the larger municipalities, there are some more specific breakdowns. For example, in Catania, there are the various neighborhoods, and they describe the commuting movements at the level from one neighborhood to another. So you understand that there are, for example, just for the metropolitan city of Catania, 200,000 rows. For larger metropolitan cities like Milan and Rome, there are more than 1 million rows for the single city. This led to the fact that I did build the database, but I built it in a somewhat particular way. Wait, I'll look for it. Let's say we need to go here. Here it is. I built it in a somewhat particular way because, you see, I built a table for each of the 15 Italian metropolitan cities. Actually, this, after discussing it with ChatGPT, but I had realized it myself even before if I wanted to. It's wrong because one should build a single large table. These data are they all have the same structure, and only this value changes, which obviously should be a column of this hypothetical large table. It is a table that would contain about 10 million rows. Now, it's not impossible to manage this type of table, but I was wondering, we'll talk about it later with chat in the discussion. I'll show you with ChatGPT. I was wondering what happens if one wants to create a form of database that is a mix between a structured database and an unstructured database. This is a mix because we have a series of tables all with the same structure. Then a problem arose. I want to run a query and find some data by summing up things that are in all these tables. How can that be done? Well, I'll tell you right away that I had some problems. And in fact, if I show you, I'll show you what ChatGPT wrote for me, the query, which I will also publish so you can follow it. I asked ChatGPT how to do a query, let's say, of this type, which this one doesn't work. It's clear. Let's be clear. I asked if a solution could be found for a query that would pull data from many different tables without having to specify the table names, because this time there are a lot of them. I could just list all 15 tables here. That's not the problem, but I'm wondering what if these tables were 100, 1,000, if it were difficult to have all these names. So, can a syntax like this work? I saw that it doesn't work directly. What can be done in SQL? ChatGPT's answer was obvious. It's better to unify the tables, work with a single large table. So in the end, what is the result, let's say, of all this work? We can perform some processing. At this point, we have built a database. We have reflected a bit on whether it was better to make it structured or unstructured. This too, let's say, opens up a very long discussion. There isn't time to go into depth. You can read this chat in a few days because I still need to fix a few things in the code, and then I will publish it on my GitHub channel, Iacono Manno. And let's see a bit then at this point the actual application, right? This was used to build the database. This is the application that does the processing. And well, what do we have? What can we do? With this